Okay, so right now we're going to look at Unit 3, Worksheet 4, Interpreting Graphs of Accelerated Motion. Object A has a position versus time graph, where it's curving all over this graph. There are 4 parts to this question. The first part is where on the graph above is the object moving most slowly? How do you know? Second part, between which points is the object speeding up? How do you know? Part C, between which points is the object slowing down? How do you know? And part D, where on the graph above is the object changing direction? How do you know? Well, this is a position versus time graph. The slope of a position versus time graph tells us the velocity. So that's going to be one thing that we need to make sure we always remember about position versus time graph. The slope of a position versus time graph is equal to the velocity. We can know that because we know that if we need to calculate a slope on a position versus time graph, that's going to be equal to the change in position over the change in time. So, in order to answer part A, where on the graph above is the object moving most slowly, and how do you know? We just need to look to see where the slope is going to be the lowest. At point A, this is going to be the slope of the line. At point B, that's the point of the line. C, D, E, F, and G. Anytime we see a flat line, that indicates the slope is 0. So if the slope is going to be 0, then that means that the velocity should be 0 at those points. So B and F both have a slope of 0 because the tangent lines, those lines that connect to the curve at a single point, are flat. So where on the graph above is the object moving most slowly? It's points B and point F. We know that because the slope of the line is 0. For B, between which points is the object speeding up? Well, speeding up means that the velocity is getting further and further and further away from 0. Or, on this type of graph, it means that the angle is getting steeper and steeper and steeper. We know at A, the object is moving. It has a positive slope. At B, it's going to have a flat line. So it's not going to be speeding up there because it goes from moving to not moving. However, at B, it's not moving. C, it is moving. So this region of the graph, B to C, is where it's speeding up because it goes from not moving at B to moving at C. So B to C is one region where it is speeding up. F to G is another region where we go from not moving to moving. So we can say that that is where it would be speeding up as well. Now the region from C to E on this graph, it looks like it's going to be a straight line. So from this region, it's a constant slope, which means that we have a constant velocity. So it's neither speeding up nor slowing down in that region. But speaking of slowing down, that's what part C is asking for. Between which points is the object slowing down? Well, we've kind of already answered this, because at B, the object is not moving, and at A, it was moving. If it goes from moving to not moving, that would mean that this thing is going to be slowing down. How do we know? Moving to not moving. We also know that at E, it's moving. At F, it's not moving. So this region of the graph is going to be where it's also slowing down. And finally, for part D, where on the graph above is the object changing direction, and how do you know? Well, an object changes direction. Well, I suppose it's going to change direction if its position is no longer increasing. So from the start to B, the position is always getting bigger and bigger and bigger. But from B on, the position is decreasing. So, because the position is no longer increasing at B, but instead decreasing, we know it's going to be changing direction. From B all the way to F, the position is constantly getting smaller and smaller until point D where the position is 0, but then it's getting more and more negative, which means it's going in the opposite direction. So, at F is where it's the most negative, position. And then from F to G, the position is getting smaller and smaller and smaller. So where on the graph is the object changing direction? At B and F, because the position is, well, for B, going from increasing to decreasing, and part F going from decreasing to increasing. Now, there are regions of the graph that we have not talked about before A and after G. But because those aren't really points on the graph or between points, we don't necessarily need to talk to them, but we can. Before A, it looks like this is going to be maybe a constant slope, or the fact that it looks like it's going to be slightly curving at 0 means that the slope at a time of 0 seconds might possibly be 0. So from the origin, a time of 0 seconds and a position of 0 meters, to point A, it looks like it might possibly be speeding up if we were to really exaggerate and make it look like this. Or alternatively, if it were a straight line, one could argue that it is a constant velocity in that region, so it's neither speeding up nor slowing down. Where there's a region where it's not ambiguous is past G. Because past G, the slope is getting less and less and less steep over time, which means it would definitely be slowing down. It's not something that I'm going to be including in my answers here because it's not really points on the graph or between points that we know, but it's just something to be thinking about.